Let's continue this paper, which is 2021 May, June, and variant 2. So I got to know that this paper was found tricky by a lot of people, and let's try it out. Let's see how we can, understand these questions. So let's go for question 1, which is apparently from experimental chemistry. The formula for magnesium oxide can be investigated by using the fact that when magnesium is heated, it reacts with oxygen to form magnesium oxide. Which apparatus is used for this investigation? So over here, obviously you're going to be measuring the mass of magnesium. You're going to be measuring the mass of oxygen, or perhaps the entire mass of magnesium oxide, and then you will subtract the mass of magnesium from the mass of magnesium oxide, because you can't measure the mass of oxygen, you can't measure the volume and then the mass already. So you don't need any gas collection. There is no gas escaping. You are not reacting any acid with a carbonate or something like that. You're obviously going to need a mass balance, and obviously you're going to be heating it because there's a mansion of heat. So you're going to need a crucible. So it has to be D for doctor, 2 and 3. There is no gas escaping, so no 1. Which property of a liquid ester can be used to check its purity before use as a food flavoring? So you just want to verify that the substance is pure. So they don't have color. Smell could be misleading. There could be multiple substances with the same smell. There are so many substances soluble in water, but boiling point is specific to a given substance, and pure substances have a very sharp boiling point. Which separation method would give pure samples of both substances from the mixture? So if you have a mixture of copper sulfate, crystals, and water, separation method could be crystallization. Okay, let's park it. Ethanol and water evaporation, because ethanol could evaporate, water could evaporate, both can evaporate. Salt and sand. You haven't talked about adding water, so they're still talking about filtration. Let's see. Nitrogen and oxygen, fractional distillation. It works on the basis of boiling point. The problem associated with option C is that even after filtration, there is a chance that some of the salt is going to remain on the residue. So the salt won't entirely be separated. Copper sulfate crystals and water. When you crystallize, the crystals are still having some water on them. That is known as a water of crystallization. And the crystals are going to be wet, so they are not completely pure. They need pure substances, and they need the separation of both. You're losing water in crystallization by evaporation. You're losing the water in evaporation, obviously by the same method. Nitrogen and oxygen can be both collected one by one through fractional distillation. An aqueous solution of J is a colorless solution that contains cations and chloride ions. Separate samples of the solution give a white precipitate, so they're talking about white precipitate with few drops of aqueous sodium hydroxide, which means it could be aluminium, it could be zinc, it could be calcium, and a few drops of aqueous ammonia. Okay, which statement about J is correct? The cation in J must be aluminium. The cation in J must be iron. It can't be iron, because it's not colorless, so that is a categorical no. When dilute nitric acid and aqueous barium nitrate are added to an aqueous solution of J, a white precipitate is formed. Barium does not give a precipitate with chloride. When dilute nitric acid and aqueous silver nitrate are added to an aqueous solution of J, a white precipitate is formed. That is totally true, because silver ions react with chloride ions to produce silver chloride insoluble precipitates. Option A is incorrect because we are not sure what is going to be released over here. It could be aluminium, it could have been calcium, it could have been zinc. Gas X has the following properties. It's colorless, no effect on either damp, red or blue litmus paper, so it's not acidic or basic. No effect on lime water, definitely not carbon dioxide. It is flammable, so it is some kind of organic compound or could be combusted. Ammonia gives red litmus to blue litmus. Chlorine, they're saying it's colorless. Chlorine is pale green, so can't be chlorine. Hydrogen is flammable. Hydrogen has no effect on litmus paper. Hydrogen is colorless. Oxygen has an issue with it, because when we talk about oxygen, we can't call oxygen as flammable. Oxygen is used to heat other substances. So oxygen is a substance which is itself, you can call it flammable, but actually it is used to inflame other substances. So it's gonna be C for cat, because hydrogen is good flammable substance. Oxygen, is the opposite of it. Which statement about states of matter is correct? When a liquid freezes, it becomes a solid and energy is released. So when particles are coming closer, energy is released, okay, which makes sense. Whenever particles come closer, whether to make a chemical bond or to just, become more closer, they release energy. When a liquid reaches its boiling point, it becomes a gas. This is called evaporation. No, sorry, that is called boiling. When a liquid changes directly to a gas, this process is called condensation. No, sorry, that is called sublimation. When a solid melts, the particles get further apart and have less energy. No, sorry, liquid has more energy than a solid's energy. So obviously 6 has to be A for apple. Use the periodic table to answer this question. Which two particles have the same number of electrons? Argon has an atomic number of 20, so 20 electrons. Argon has an atomic number of 18, so 18 electrons. Calcium has 20, so argon electron is 18. Calcium has an electron number of 20. Not true. Sodium has an atomic number of 11, so sodium plus has 10 electrons. And when we talk about potassium, so potassium ion has 18 electrons. Again, not true. Iron has an atomic number of 26. So iron ion over here has how many electrons? It has obviously plus 2 charge, so 24 electrons. And when we talk about iron 3 must have lost 3 electrons, so it has 23 electrons. Calcium, again atomic number of 20. So calcium has how many electrons? Calcium, it's not calcium, it's calcium ion. So calcium ion over here has again 18 electrons. And when we talk about scandium has an atomic number of 21. So after losing 3 electrons, it becomes again 18. So D for doctor is the right answer. The table shows data for particles W, X, Y, Z. Which statements are correct? Let's see. W has 6 protons, overall 12 nucleons, number of electron is 6. W and X are isotopes of the same element. Let's see. W and X have both same proton number, but their nucleon number is different. So yeah, that is true. Y is in group 5 of the periodic table. Y has 7 protons. Let's write the configuration 2, 5. So Y is indeed in group 5 because in the last shell it has 5 electrons. Z is a cation. So does Z have less electrons than the protons? Let's see. Z has 10 electrons and 6 protons. That is not true. Z is apparently anion. So 1 and 2 are the only correct statements. Which dot and cross diagram correctly shows a molecule of ethene? Ethene has 2 carbon atoms joined together by double covalent bond, and then there are overall 4 hydrogen atoms overall here. So it has to have a carbon with double covalent bond. A is wrong, C is wrong, either B or D. Now there are 4 hydrogens. D has 6 hydrogens, that is wrong. So B for Barrows is the right answer. The names and formula of 3 nitrogen compounds are shown: ammonia, hydrazine, hydroxylamine. Which compound has the highest relative molecular mass, and in which compound is the percentage by mass of hydrogen the greatest? So let's find the MR. MR for ammonia is going to be 17. It's obviously 14 plus 3. Hydrazine is it going to be 28 because there are 2 nitrogens and 4, so it becomes 32. Hydroxylamine is 14 plus 3, which is 17 plus 16. So it's going to be 17, 27, then it's going to be 33. So they were looking for the highest molecular mass. It is going to be hydroxylamine. and then they're looking for the greatest percentage by mass of hydrogen. So let's see. In terms of ammonia, when we compare ammonia and hydroxylamine, you can see they have the same number of hydrogen, but it has less molecular mass, ammonia, and hydroxylamine has a higher molecular mass. Both have 3 hydrogens. So obviously ammonia would have higher percentage of hydrogen as compared to hydroxylamine, because out of lesser mass there is the same number of hydrogen. So obviously the answer is going to be C for cat. I'm not going for hydrazine because hydrazine has a higher mass compared to ammonia, and still hydrogen is only 1 more. So we need to sometimes use our trick and sometimes our mental math to just compare values. They're not looking for the answer, they're looking for a comparison. So in terms of comparison, we can directly find that out of lesser molecular mass, ammonia has more hydrogens out of here. Let's go for the other question. The relative formula masses of 4 compounds are given. A student has 1 gram sample of each. Which sample contains the highest number of moles of oxygen atoms? So oxygen atoms highest number of moles. Let's see. So it's again a comparison because each time you have only 1 gram. So what you can do is they're also concerned with oxygen atoms. So you need to count the number of oxygen as well. So it's going to be 1 over 102 times 3. For option B, it's going to be 1 over 80 times 1 because there's only 1 oxygen, so no 3. In option C, it's going to be 1 over 98 times 2 because times 4. There are 4 oxygen atoms. And in the last option, option D, it's going to be 1 over 63 times 3. So it's 3 over 102. It's 1 over 80. Second is 4 over 98 becomes 2 over 49, and then it becomes 2 over 49, so it becomes 2 over 49, and the last is 3 over 63, which becomes 1, and then it becomes 21, so 1 over 21. You just have to do it on calculator, you get the highest answer. When I do it on calculator, my answer is turning out to be 1 over 21 is the highest one. Because obviously out of let's just do some mental math. Out of 1 over 80 and 1 over 21, this one has to be higher. And again, out of 2 over 49 and 1 over 21, this has to be higher. So I'm not comparing it even 3 over 102. You don't have to do it mentally, you can do it on calculator, which is something I would suggest, because sometimes when you're doing the exam, mental math goes out of the window. So it's okay to use your calculator for even smaller things. Just have confidence in yourself, you're going to do great. 10 centimeter cube of propane is burned in 70 centimeter cube of oxygen in a closed container. What is the total volume of gas present after the reaction? Assume all the volumes of gases are measured at room temperature. So again, room temperature means water is liquid, as they have mentioned. So don't count water. Out of the propane and the oxygen's ratio, 1 reacts with 5, and in terms of carbon dioxide it produces 3. If you have 10, it should react with 50 and should produce 30 of carbon dioxide. So 10 centimeter cube reacts with 50 centimeter cube to produce 30 centimeter cube of carbon dioxide. If you had originally 70 centimeter cube oxygen, you subtract the 50 because it has reacted, and what is the remaining? 20 centimeter cube of oxygen remains, and 30 centimeter cube of carbon dioxide has been produced. So the remaining oxygen is 20, and newly produced carbon dioxide is 30. So total volume of 2 gases is going to be 50 centimeter cube. B for Barrows is the right answer. Now question 13 says, when a mixture of sodium chloride and sodium hydrogen carbonate is heated, the reaction shown takes place. You can see carbon dioxide is being released, water vapors are being released. Sodium chloride is unchanged on heating. Okay, we know that. When 6 grams of the mixture is heated, the loss in mass is 1.5 grams. Maybe it belongs to the carbon dioxide and the water. What is the percentage by mass of sodium hydrogen carbonate in the mixture? Now you need to find the mass of sodium hydrogen carbonate. Okay, Now we need to look at the fact that 1.5 gram of the substance has been lost. We need to find the moles of the substance lost. So mole is equals to 1.5 grams divided by the mR. But my question is, what is the mR? Because these are two things. So let's put the mR together, 44 plus 18, because you are considering 1.5 grams to be having the carbon dioxide and water both. So let's put both. So it's going to be 44 plus 18, and that's going to be 62. So you're going to be finding the moles of both substances together. It becomes 1.5 divided by this sum, which was obviously the molar mass of both, 0.0241. 0.0241. Now this is the moles of water and carbon dioxide both, 0.0241 mole. You can see the relationship between these substances is 1 and it is 2. So it's going to be double the moles of sodium bicarbonate or sodium hydrogen carbonate. So moles of sodium hydrogen carbonate is equals to double this value, which is 0.048. 0.048 is the moles of sodium hydrogen carbonate. Now what's the mass? The mass of sodium hydrogen carbonate is times the mR. You just multiply the molecular mass by moles and you get the mass. So the mR is given to be 84. So 84 is given, it's multiplied, and you get 4.06 grams. Percentage is 4.06 divided by 6.0, because that was the total mass of the substance. You get 67.7%. 67.7% is going to be C for cat. Molten sodium chloride is electrolyzed, which change occurs at the cathode. So at cathode you have sodium ions and chloride ions. Sodium ions are going to go to the cathode. They're going to gain electrons to become pure sodium element. So sodium ions are reduced because gaining electrons is called reduction. Which positive ions are present in aqueous copper 2 sulfate? So copper ions and sulfate ions are definitely here. H plus ions and OH minus ions because water. So they're asking for positive ions. My answer is going to be both these. So copper 2 ions and hydrogen ions. B for Barrows is the right answer for question 15. Natural gas is used as a source of energy. What is the main compound in natural gas? Now that is general knowledge. That is obviously methane. Question 17 says, ethanol is produced by the fermentation of glucose from sugarcane. In some countries, ethanol is used as a fuel. Which statements are correct? Sugarcane is non-renewable, a finite source. So it means that sugarcane is not infinite. It's gonna be you're gonna run out of sugarcane anytime soon. I don't really believe that because sugarcane is renewable. You can grow new sugarcanes every year. When sugarcane is growing, it removes carbon dioxide from the atmosphere. That is very true because they perform photosynthesis. So statement 1 is incorrect, 2 is correct. B for Barrows is the right answer. Aqueous sodium thiosulfate reacts with hydrochloric acid. The rate of the reaction increases if the concentration of both reactants is increased. Nitrogen gas reacts with hydrogen gas. The rate of the reaction increases if the pressure in the reaction vessel is increased. Which row correctly explains why the given change increases the rate of reaction? So when you have aqueous sodium thiosulfate and hydrochloric acid, you're obviously not altering the activation energy. You're not using a catalyst. You're just providing a higher frequency of collisions. And again, when you are decreasing the volume, the particles of nitrogen and hydrogen are coming closer. So again, a higher frequency of collisions, not activation energy. So A for apple is the right answer in this case. Magnesium reacts with dilute sulfuric acid. 2 experiments are carried out at 25 degrees Celsius. Experiment 1 and 2, you can see both have 24 grams of magnesium. Both are powdered magnesium. Then it says reacted with 100 centimeter cube of 1 mole per decimeter cube sulfuric acid. Mole is equals to 100 times 1 divided by 1000, which means 10. And then it says in the second experiment, it says 50 times 2 divided by 1000, which is again a similar answer. I should correct it. 0.1 and again 0.1 over here as well. Both have the same moles. You can see same moles of the acid in both cases, but this one is more concentrated, so experiment 2 is apparently more concentrated. You notice one thing, that the number of moles are same, so the product should be the same, the graph should reach the same height, but experiment 2 should be faster. So let's see. C and D can't be the answer because you need to produce the same amount of the product. The amount of reactant was the same, so it has to be A or B. Now since experiment number 2 was faster, it should have a higher slope, so A for apple is the right answer. They should have the same amount of product, but the higher concentrated acid gives you a faster rate of reaction. Solution X is colorless. A few drops of aqueous potassium iodide, which is Ki, are added to the sample of X. No change is seen. So it means X is not oxidizing agent, because if it was, it would have reacted with Ki. Solution Y is colorless. A few drops of aqueous acidified manganate are added to the sample Y. The color disappears. So there is a reaction. It means Y is reducing agent, because with potassium manganate only reducing agents react. X and Y are both reducing agents. No, sorry. X is an oxidizing agent. No, sorry, we just established it is not. X is not a reducing agent, maybe because we don't have enough info on that. Y is an oxidizing agent. No, sorry, Y wasn't an oxidizing agent. Y was a reducing agent. X is not oxidizing agent, yes, and Y is a reducing agent, yes. So D for doctor is the right answer in this case. So let's keep it till here, and the very soon upcoming video we're going to be doing the rest 20. Stay tuned guys. Thanks.